If the physics we've talked about so far felt like common sense, get ready, because this is where common sense goes to die. The great Richard Feynman himself said, "I think I can safely say that nobody understands quantum mechanics," and he explains why by focusing on one single experiment that holds the very heart of this strange new world, the double-slit experiment. First, let's set the stage. Imagine you have a wall with two slits in it. If you fire a bunch of bullets at it, what happens? Simple. They go through one slit or the other and make two distinct piles on the back wall. They behave like particles. Now imagine sending water waves at the same wall. The waves pass through both slits, interfere with each other, and create a complex pattern of high and low points on the back wall. That's how waves behave. Okay, so are electrons bullets or waves? Let's find out. We fire electrons, one by one, at the double slits. Now, electrons are particles. They arrive at the back wall in individual lumps, just like tiny bullets. So, we should expect two piles, right? Wrong. If you let the experiment run and look at the final pattern, the electrons have arranged themselves into an interference pattern, exactly like the waves did. This is wave-particle duality. Each individual electron, which should only go through one slit, somehow acts like it went through both at the same time to create this wave pattern. It's as if it knows both slits are open. This is where it gets even weirder. What if we try to peek and see which slit each electron actually goes through? We can put a little detector, like a light source, by the slits. The moment we start watching, everything changes. The electrons stop making the wave pattern and go back to behaving like bullets, forming just two simple piles. The very act of observing which path the electron took forces it to choose a path, and the wave-like magic vanishes. By watching, we change the outcome. This leads us to a profound conclusion. We can't know everything with certainty. This is the core of Heisenberg's uncertainty principle. The more precisely you know where a particle is, the less you can know about its momentum, where it's going. Nature has a built-in fuzziness. We can no longer predict exactly where an electron will land. We can only calculate the probability. This chapter is the end of the line for classical clockwork thinking. The universe isn't a predictable machine. At its deepest level, reality is a beautiful and mysterious probabilistic dance. And while we've figured out the rules of this quantum game, the game itself is far stranger and more wonderful than we ever imagined.